Hello everyone, welcome to Sine Studio. I'm Muhammad Jama, founder of Sine Studio. Today we will take the first course about the Grasshopper online sessions. So today we will learn how to think parametrically and how to use parametric tools in architecture. So let's start by defining the Sine Studio. Sine Studio is architecture firm that is company related to architecture, providing many services like teaching architecture software and concept design and computational designer, and many like specific related to the architecture like BIM modeling or real estate design. So our vision is responsive architecture can turn performance into form. So our goal to push the boundary what is possible. So we always work with the language which is parametric design, minimalist, sustainability, and integrate with biomimicry design. So I'm Mohammed Jama. I was born in Damascus, Syria, 1996. I graduated from International University for Science and Technology in Damascus. Then get the master degree in BAU that related to master in architecture in general. Then I worked with Reparametric Studio for 5 years. Then I launched my Sine Studio that related to architecture firm providing many services. So we always looking to collaboration and remote work and to providing many architecture project like conceptual design and project as real. So we also provide that not just by teaching, we provide the project in order to push the boundary and enhance the concept quality by using the parametric design approach in architecture. So for example, here we have the first project, which is Helixa Tower in Dubai. That was in 2025. That office building and commercial. The language is parametric design. And here you can see the diagrams about that project. So always for each project, you have to add many details about that related to like diagrams, site and footprint area, the mass, the total built area, environmental analysis, viewing, and the final mass. There is a lot of analysis there, but not all published here in the portfolio. Also here we have another one, which is competition, Ecosphere Energy Research Center that was in Iceland in 2025. That was competition. So the category is educational. Also the same here, diagrams showing the concept, how that's developed. And here we have waveline towers, also that office building commercial category. The language is parametric design, sustainability also. And that was in 2024 in Dammam, Saudi Arabia. The same here, another office building that also in Saudi Arabia, in Riyadh, that was in 2024. So all the concepts is related to the site and the environment related to that city. So for that reason, parametric design, when you design anything related to the site, so that will be original with that site. You cannot use that building or that design in another site because that's related just for that design. If you want to apply that design to another site, you have to change parameter in order to make that adaptive with another site. So for example, here we have many parametric skyscrapers that not just generated by Grasshopper, but also develop the parametric design approach, how we can control the project here like that one. And we explore many design and always focus on you learning a new thing related to architecture. Don't say I'm rich the top and I don't want to learn anything else. No, stay learning every time. I still learning in every time, reading book, watching videos, and explore many things related to architecture by doing many computational design and attend to competition architecture, so that develop my skills. So also here you can see parametric building that also generating by RHINO and the Grasshopper that is useful for me because the RHINO and the Grasshopper provide many details and easy to use for computational architecture. So also here you can see parametric stadium and many forms that form not just like complicated form. It also has like a system related to the nature system from nature. We will talk about that, like biomimicry and behavior structure. We will talk about that now. So also here you can see parametric facade, that kinetic facade, it's adaptive reuse with the environment. You can see how that's work with aesthetic architecture. So here also parametric bridges, also here parametric stairs. So that means about the structure element or something related to something, it should be 100% accurate because that like stair, so 1 milli it will be for that design. So also you can do that by Grasshopper. Here parametric furniture like benches or parametric wall or something like lighting element. So we provide many architecture software like RHINO, Grasshopper, Revit, V-Ray for RHINO and Lumion. So Sine Studio on all social media, you can watch all of them like YouTube or on official website, Instagram, Pinterest, TikTok, LinkedIn, Twitter, Telegram, and here we collaborate with another firm. So that was about the general information about the company. Here we will talk about our session today. So the Grasshopper session today, we will focus on the thinking in parametric design and how you can apply that in your project. So for example here, what is parametric design? So parametric design is a computational approach to architecture where design elements are driven by algorithmic rules and adjustable parameters rather than you creating fixed form or architect defined relationship and behavior, allowing form to adapt dynamically based on environmental data, structural performance, or user defined inputs. This method enables the creation of complex, efficient, and responsive geometry that integrate aesthetic with function. So also I want to mention something related to parametric design. So when you say parametric design, that not mean it should be complicated form. For example, if you have box and another one like that form, for example, if you have single box and that form, so you can say both of them parametrically, both of them created according to parametric design. Even if you have single box which is like a single windows, so parametric design that not mean you have like unit array around the form, or that will be complicated, or something related to something like Zaha Hadid style or Bjarke Angels, Thomas Etherweek. So all of them work as parametric design. But I want to mention something else. Parametric design divided into 3 categories. So the first aspect of parametric design, it should be when you have like project and you want to do that according to parametric design, you have to do that like this: approach, inspiration, and tools. So what is the approach? Approach that related to the parameters, that related to architecture parameters like site analysis, the environmental analysis, and the, for example, like function, and the factor it will be from site or the client requirement, and the design process of that, like related to our parametric design. When you design anything in parametric design, after each phase you have to evaluate your design if that's efficient or not. So that's the approach of parametric design. Like always try to generate something different in order to get the best result. That about the approach. The second one, inspiration. So the inspiration, it could be from nature system in order to understand the materials, the shape, the behavior, the function, the structure. So many architecture firm learn from nature and apply that in his project. For example, the Hadid, inspired by like from nature many times, and she used like materials or shape or behavior or function, not just like shape. If I like find from nature system like anything like a star from the, or so that mean not I want to create shape like star. So that means inspiration in order to analyze that product or that object from nature according to material, shape, behavior, function, structure, and apply that system which is work correctly in the nature system. So you can apply that in architecture. When you apply that in your project, that will be the second sector in parametric design. The third one, which is our work now, which is tools. So parametric design that did before 100 and 500 and 1000 years manually. So you can see like gouting or something related, not could be not like sketching, could be like another techniques. We cannot know about anything about that. So the second one, like coding, like Grasshopper, Python, C++, or RHINO, and the new revolution, which is AI. So always I want to mention something related to AI. So if you want to work with AI, so focus on to control on AI, not AI control you. That means apply the AI and integrate that with your work without make that control you and just generating something. You cannot do that by softwares, or you cannot understand the architecture approach about that one. So how Grasshopper work? So for example, you can start with the first basic element, which is point. From one point you can create line, then you can create closed line, you can create like vertical line in 3D, then you can create like a single surface, and then to create like 3D, then you can edit that one, and here you can get another result. So when you apply all these steps to get that one, so if you change the location of that point, you will get another result. So for example, if you change the diameter here for that rectangle, that will be effect on the final result. So that's how the Grasshopper work. So here we can do like something related to a tractor point here, and here like stairs. I show you that, and top architecture frame using Grasshopper like Big, UN Studio, Foster and Partner, Mad, and Zahadid. So if someone looking to attend and to be architect there in many firms like Big, UN Studio, or anything else, so if you have like Grasshopper and that approach of parametric design, you will be able to attend to these firms like this. So also I mentioned that Sine Studio on social media. So also I want to mention something before start our session. So here you can see the official website here, sinestudio.online. So you can see the Sine Studio provide many services like concept design, architecture design, and academic course, learning software. And here you can see the YouTube channel, our courses. You can attend to the course, and there is many product there. You can buy product on our website, and here the project review and collaboration. So the project tabs, you can see the project, the same here. I mentioned that before. Courses here, you can see the Grasshopper private online course 1-to-1, Grasshopper recorded course in English, and the Grasshopper online course by group. Also here, the same with the RHINO private online course 1-to-1, RHINO recorded course in English, RHINO online course by group. So also here we offer new thing that two courses, RHINO and the Grasshopper recorded course. You can get this, and here you can see the reviews from our students. And here's the shop. You can download any file you want from Grasshopper and RHINO. So you can find all the product there. So that was the first thing and related to the Sine Studio. So let's move to our session today. So, Grasshopper work in here in this Canva, and here we will see that visually. So we will start with the first one, which is this skyscraper. So I prefer always to do everything inside Grasshopper without drawing anything here in RHINO and link that's in Grasshopper. So that not like false, that correct, but I prefer to do that everything in Grasshopper because you will save your data inside the Grasshopper file, and you will change any parameter that will change everything there. So always start with bifocals in order to see the name above the component. So you can download that from Food for RHINO, and here let me see here. Yeah, so bifocals here. So always start with the point. So because every 3D model starts with a single point. So the first point, if you have like single point, you can create line from 2 points. You will create that line. Then you can create like closed curve by array that curve. Then you can create like surface. So that one. Then you can create like 3D model. So all of them created by from first object or elements. So then you can edit that one in order to get different design. So the process of a Grasshopper, when you want to model anything, we always start with the point, then curve, then surface, then 3D model, then you can edit that. So each definition will start with the point. So let's start our definition with the construct point. So construct point. I will do that as simple as possible. I know maybe some of you like advanced in Grasshopper, someone beginner. So for that reason, I draw all name component above the component and display the name and full icons here in order to understand the component. And also if I use any plugin, I will mention that in order to download and work that by yourself. So here we have the construct point, and here you can see 3 inputs. First one, which is X, second one Y, third one Z. So if you add parameters like 5, yeah. So let me see if everything's go okay. Okay. So you can see streaming, that's okay, right? Let me check if that's worked correctly. Great. So the first parameter, you can link that with the X or Y or Z. So if you connect that with X or Y or Z, you can see how that changed the location X, Y, Z. So now I will keep it in Z 0, 0, 0. So now I will use circle. So now I will use that one here, the point with plane. So centroid of this circle will be there, and here we can connect that parameters with radius. Now we want to move that curve in order to get that one. So you can see that curve here. So in order to move that curve, you cannot move that directly like this. So if you move that directly in Z direction, for example, if you connect in Z here and in motion, so you will see that move without any variation, like all of the curve in the same plane. So for that reason, we'll use divide curve. So if you have any project and you want to apply that in Grasshopper, so start with analysis, even if that take like 1 hour, 2 hours to analyze the shape before doing anything in Grasshopper. So for example, here I will analyze that one. So I start with a circle, here I have another circle, and here we have another curve, and we have like many curves between that one and this one. So that means I use like something called between two curves. So I think like RHINO, and I want to apply that in Grasshopper. So for that reason, analysis before start with Grasshopper, you will keep you doing that quickly without making any mistake. So let's do that together. So that's not correct here. So I will connect the circle with the curve, so that divide into many points. So now I will add divide curve and the count of points, so that will affect on the Z move. So here, if I want to move that one, if you connect move here, the same result there. So for that reason, we will use graph mapper. So always a graph mapper come with range like left hand of graph mapper. So if you connect that directly with a step, that's not correct. I will show you that's why. So here the count one is 11, and here the output is 12, because the number here 0 in algorithm, that is the value. So for that reason, we need to add like subtraction here, just one value, in order to remove just one value from that one. So here you can see the output 11. Here we have 11, so that's correct. And here we can use any one you want. For example, you can use sine. So let me complete that one. So we will use construct domain, and here the bound and remap. So what is this component? The first one will calculate the minimum and maximum value. So you can see here we have like the minimum value, here we have the maximum value. So we have to connect that one with bound in order to calculate the minimum and maximum. Then bound with source, and here the graph mapper with value in order to calculate the main value. And here construct domain, and the construct domain start with and end. So because here we use the move option there, so we will apply that one, which is parameters according to the Z. So for example, if you use like rotate, you will use like 45 degree, 60 degree, 120 degrees. So according to the item there, which is this component. So if you use scale, you will use between 0 and 1.5, for example, or more, but a little bit, like maximum 3 or 4. So we will start with 0, and here with 12. And you can see if I connect that one with the Z, so I will show you how that's look. So you can see that's how that look. You can see that's the first one, which is here. So you can see that one I will show you that's another method here in order to match that with the grasshopper. So imagine that this value for this point, and here's the intersection between the red line and with the black one. Here we have another value which is between 0 and 12. So for example here around 1, for example. So the first point, which is in Z direction spacing, so the first one will get like 1, second one will get like, for example, like 0.3, and second one or third 0.6, and you can see that here to return to the last one. The last one will get the same. So that graph reflect how that's apply in 3D. So if you change the sign, you can see how that's affect. Also, if I apply pointless in order to show you that's how that's work. Pointless in order to see the number. So 0. So you can see 0 is the value. So the total is 12, 11. So that was 12. We remove just 1 in order to make that 11. So the 0 value will be there. The 10 will be here. So you can see that the 10 is get this point here. So that means not 0. That between 0 and 12, that like you can see the value there by using manual, connect with mapped, and you can see the number 10 0.6, and the first one 0. You can see the maximum one, which is 12. If you increase the number there, for example like 15, you can see how that's changed there. 15, 12.2, 7, 2.7, and here 0.8. So that about how to read the data there. So I will return that one, and here I want to create the curve from that point. So we will use interpolate curve, connect this point with the interpolate. So the problem here, the curve is not closed. So in order to make that close, so here we can use like toggle in order to make that false or true, or 0, 1, or like switch on, switch off. So that is language of coding. So if I connect that true, you can see how that's close. So I will hide everything here in order to see that correctly. So that's the first curve. You can see here the first curve there is created by using graph mapper. Here I have another one which is like another curve in 3D. So let's see how that will work there. So we will use the same approach by using like this definition. I will copy everything there like this and create something like increase the value there, but that's not correct. I will show you why. So for example here I have the second curve and changing like the perimeter there, that will be not much with the first one. So for that reason, let me hide that one here. So the graph here is different from second one. So for that reason, even if you change the value here, that curve will change. So when you make like twin between two curves or loft, so we will face problems. So for that reason, if you have the same definition, you want to match with two curves, and you want to apply the same graph with the same parameters, that will be fixed and will be changed just for like essential thing. So that will be shared with another one. So for that reason, I will delete this one. I change the graph to make that like Gaussians, and we can create like this. So that's okay. And here, if you want to apply another curve there with different value, just get all of this copy to get another one. So now this graph mapper connect with two definitions, with this one and this one. So that will affect this first curve and second curve. So if I change the parameter there, I will get another curve there according to the same graph mapper. So if the graph mapper change there, will it change in two curves. So I duplicate this one in order to change the height. So here's 17, 8. I write parameters in order to make that exactly the same. And here you can see the first curve, second curve. So if you have two curves, you want to apply that, think like RHINO. If you have two curves and you are using RHINO, so you will use like between two curves in order to create many curves between the curves. So now we have curve A, curve B. So that's the first curve, and here we have the second curve. So the factor there will be 1. If you connect that directly like 20, for example, that will not work. So because you have to use like range options, range component there, in order to add like how many curves you want to apply there. So the default one is 10. I will apply 26. And here you can see how that many curves apply there. So now you can see that many curves created like the reference. So let me see there. So many curves created here. So but here I see that like the curve is scaled in one direction. Maybe it's that scale or maybe offset. So after analyzing that photo, you can decide which component you have to use. So I think that's scale 1D because that's in 3D here or another dimension. That's the same, just in this direction effect from the scale. So now we will use scale NU. Scale NU, the difference between scale NU and scale here, scale in 3D, here you can define like X, Y, Z parameters so that our geometry, and here if you apply, for example, that one, we can apply scale according to graph mapper again. Let me show you how to do that. The same here, when you use graph mapper, you want to create like graph mapper and range and subtract one value in order to make that the total one here after range 26 match the same value there. So here graph mapper again, and also here we can use like the same Gaussians, and we can change to make that like this. Okay, and the same before. First one construct domain, second bound, and third remap. The same graph mapper with bound in order to calculate minimum and maximum, bound with source, construct domain with target, and here the graph mapper with the value. And here, because we work with a scale, we will change the value. So before we use the graph mapper to the move components, so we use like this parameter between 0 and 12 because that according to the move, but here we will use the scale according to the parameters that related to the scale, like between 0 and 1. So start this with 1, and here second parameters, and we can connect that for example in X direction. If you connect that with X direction, you can see how that's look. So The plane here, the original one, which is here in the centroid of the circle. So instead of using that one, we will use another thing, which is point on curve, to get the centroid of the scale will be there. So I will make that like in the middle here. So that is the plane for all these curves. So you can see how that's effect there. I will hide everything before in order to see that correctly. So now we can use offset curve. Offset curve. I prefer another one, which is here, this one. So you can download this plugin, Bufferfish. That plugin is better for offset curve and to provide like between two curves also. So install Bufferfish and the bifocals in order to draw the full name above the component. Yeah, so let's move to the offset. You can use offset here. 1.5 here. So you can use offset, you can use a scale. So let's see the reference there. So you can see here that the first curve, which is near from the glass, that created, and the offset one, which is already created, this one. So now we have the first curve and second curve. So now if you want to create like loft, you can create loft here. Just connect this one. You can see how that's create like glass material there. So that's the first one. And here, if you want to create curve between surface between the first curve and second curve, follow this method. Curve and make that flatten in order to make all the group as one group, and simplify in order to make that simplify. I will show you what means simplify. So you can see here in RHINO, I create that curve from first point, second, third, 4, 5, 6. So here I have 6 control points. If I use offset curve, like for example 5, so you will see that many points created not the same here. You can make that here, use that mean keep the same control point count in the new offset, but here in previous one that not much the same. Here 6 control point, here I have many control points. So for that reason we use simplify in order to make that as simple as possible. So that's the first one. Duplicate that one, Control C, Control V, or hold Alt and move it. Then change it the second one to graph here. So here we have the first data, here we have the second data. The first data here, which is the original one, and here we have the second one, and we can connect now with the loft. So here the first with second, so each one will connect with another one directly. So you can see how that's look. First with first, second with second, third with third. So I will explain that in another method. For example, here I have that first one, and here second data. You can see how that's work. So when I connect both of them with the graph here, in graph here, so make each curve in single group, for example. So you can see the first curve connect with the first, second with the second, till the end. So if you select like that's option, which is reverse, those that will be flip first one with the last one, so we'll flip the order. So now after getting that surface, you can extrude in Z direction, and here we can create like in Z direction here, and the surface connect with the extrude, and you can see how that's look. So here about the second one. So you can see here the reference. Here I created the glass, and here which is like that's element, and now we want to create the surface. So let's move to the next one. So here the challenging how to create that curve. So here we have the last curve. So we want to select this one. So we will use list item, connect with the scale in order to get just one item. So you can like add 25 parameters here to get that one, but that's not correct, because if you change the number, for example here I find that one, if you change the number there, which is for twin between, so if you change here the number to make that 28 for example, you will see that you select different curve. So you have two options. First option, to connect the same parameter there with the list like this. So even if you create or change the parameter in between, that will be not affect on that curve. That's the first one. Second option, to make that always 0 and reverse the counts. So always you will select the 0 value, which is the first one. So both of them correct. So now in order to create surface from this curve in 3D, you have many options. First option, by using patch, but I don't prefer that because we want to apply another system there. So if you connect that here, you will see that's apply there. So the patch is the first option, but I prefer the second one, subcurve in order to get like just like part of the curve. So that will be between 0 and 1. So I will hide everything in order to show you that's correctly. I will hide here this one, and here this one. So now we select this curve. So when you connect that with the domain, you cannot see that get like high value, because that between 0 and 0.5. So that means maybe I will add like 20. So that's not correct all times, because the length of the curve will be changed. So instead of using the value according to the length, we will use according to the proportion. So how that work? By using the reparameterize option there, right click on the base curve in order to make, for example here, I will explain that there. So if you have the curve like this, the length of that curve like 26 meter, okay? And when you apply that one with the subcurve without using reparameterize, so start with 0 and here end with 26. When you use like reparameterize, so that convert the maximum value to the 1. So that means 26 will be equal 1 and 0 will be equal 0. So that means according to the proportion. So you can see here, if I get like between 0 and 0.5, that means I get the half curve. So that's the first one, and here I will get another one between 0.5, and here I have error because you cannot select both values the same value. So make that 1, so you can see that's connect correctly. The same here when you want to use like the loft, flatten, simplify, and graph, connect together in order to make that correct data. Connect subcurve with the first data and second one with the second. Loft options, first one, second one, and you can see that's how that looks. So here we have problem that because the flip curve, you can flip that curve, and we have many options to create that one. So I flipped that curve because that start from left to right. So when I make that loft without flip, that's different value. So for example, here start from 0 to 1 and second one from 0 to 1. So I flip one of them in order to make that correct. So now we create this one. So here our surface there, apply. So we want to apply that patterns on that surface. So let's move on to this one here, and we can create mesh. So we convert from surface to mesh in order to using another plugins. So some plugins for surface, some plugin for mesh, some plugin for sub-D tools. So according to patterns, according to your approach, what you are looking for. So I'm looking for something related to the mesh. So for that reason, I convert from loft, which is surface format, to the mesh in order to create something else. So now I will use a quadri mesh in order to make that different values. So the mesh will be a grid of polygons there. So I want to make that according to the edge length. So you will see that's different value there. So now we will use different plugins. So Weaverbird, also you can download that Weaverbird and use that pattern. Connect this one here, and you can see how that's created. So here I have the first one, and now you can create the frame. Here we have like frame and the panel, and here offset surface or thickness. So for example, here we will use both of them. So if you connect this one with this, and here we can provide like 2022, 22, 22 here, and here we can use offset. So you can see the value there. We can use the value which is 0.5. That's look nice. So that's okay and look like a grid. That's not smooth. So you can see the reference, it's smooth, not like a grid. So like circular, not rectangular. So we can do that by using something related to sub-D here, also in Weaverbird plugins. So the first one that will make the mesh. So you can see here the input, it should be mesh. So if I keep that like loft, if I connect with any one of them, will be not correct. So if I connect with this component or this component, that will not work, because you can see here the input always with mesh, not with surface. So also here the output is mesh and connect with the input, which is the mesh. So when you use like this plugin, and especially this component, always make that 2, not bigger than 2. It could be crash the file because that heavy on the file. So you can use that twice, not more than twice, because that will be smoother now, but will take a lot of time to calculate the data. So that will be smoother. I will show you that after hitting everything. So you can see here is smoother, but if you want to edit anything before here, that will take a lot of time in order to calculate all data together. Like if you change any parameter there, will calculate all this definition till the end. So for that reason, if you want to apply this one in your final design, make that disable and just focus on the previous one in order to see the design, and also that look good. But if you want to make that smoother, keep that to the final result. So that's the first one here, and also we can apply the same with the first one here. So the first one here, which is this surface, the last one, so we can create that surface here. Let's see, after analyzing there, we can see the curve. It's not the same scale of that one, so we will make offset curve of this one in order to loft with the second one. So offset curve. So here also, if I apply like 5 with distance, that will be outer. I want to make that inside, so for that reason I will use negative. It could be like using something here in definition, right click here and use expression. I don't like this method because I want to see everything in definition without something inside hiding in the component. So I don't prefer to make that like without icon component, without this icon. I don't prefer to not to draw full name of that one. So for example, I will show you without draw icon like this, without a draw full name. You can see just shortcut, and some of people doing something like minus x or something like -1 and doing some expression like this. So I don't like that because that's not hitting expression, hitting data. So you want to find your data in order to change that one. So for that reason, I advise you to always draw icon and full names in order to see correctly. So now we will convert from 5 positive to 5 negative, connect with the distance, and you can see that's how that's look. So as I told you, when you want to use loft between two curves, you can use loft or real surface. If you want to use loft, I prefer to use that directly. Even if that's work without these components, you can do that directly, but in order to avoid any mistake with your definition. So because it could be, instead of using offset curve, you can use scale. If you use scale, that will not need like simplify. For example, here I will show you. If I use offset, you will see that it's not the same count or not the same degree, because that's degree 3 and second one degree 2. And if you use like a scale, that will be like another copy of that one. So that sometimes work and sometimes not work, because like I show you that before, by using that method, when I use offset curve, I get another curve with different control points. So here we have the first point, and here we have let's see this one. That's our curve, which is created from the first graph mapper, and here connect with this one. So we can connect with the loft, first one, second one, we connected that. So because I have already created this definition, which is related to the patterns, so I can duplicate this one. And here I will use the loft, so you can see the same. The loft there, I will use the loft here. And you can see how that's applied. So if you change the length here, you will increase the number of the pattern there. So here I have the pattern, here I have the patterns, and now I want to organize my work. So I want this one, which is a glass, so I will use merge component. The merge component is to organize your work. For example, this component for the glass material, this first one, and here we have the second one, and we have the third one, which is the main body or main skin, which is created there. This one, no, this for like the floor. Yeah, this one. So that's a third surface, which is a glass material. So here we have the glass material merged together. So also we have another one, which is a gray material. We will apply that together in one component. That's the first one. I know that's not see clearly. I will add materials in order to see that clearly. So you can apply this one here, and here you can see. So all data there inside this component. So now I want to mention something. I do a mistake there by distance because that will be offset inside. You can do that. No, that's correct here. Let me check the glass interior. If you make something so like negative, you can change the value there. So you understand the concept how to change that one. So here you have the mistake. If you change the opposite value, you will get another parameters. So here we have two materials. So in order to create materials here in Grasshopper, you have to use custom preview. The custom preview, you can link with color. That's color related to the plugin, which is named like a human. You can connect with the custom preview like this in order to see how that's look. That's the first option. And second option, you can use custom material again and connect the material, right click with the materials already added in RHINO. So for example, I will show you here the material sections in RHINO. The material tab there, I added many materials so I can see the gray materials. I apply like this parameters: glossiness, reflection, transparency, the color material, and also the same for like a green glass here. You can see double side and the custom for front, glossiness and reflection. So you can edit your materials there in RHINO, then connect directly and simply there in Grasshopper. So first one I connect with the gray material, second one with green glass. So the first group, which is green, which is gray, that one. Here we have the green glass, that one. So in order to make that easier, green glass, and here you can change the name gray materials, for example. So you can hide everything before, and you will see that's a render how that's look. So that's if you want to change anything or any parameters, save the file before doing anything before. So for example, I will make that, save it here. So if I want to change anything, so for example, the scale in this direction, so let's take a look there. So we connect the scale just in this direction. If I connect with both direction in X and Y, we will see the result there. So that's look better. So you can see how that's applies the same definition. Just change one parameter, you will get different value, different result. So that is how parametric design work in tools section, because that is parametric tools, how to change any parameters, you will get different result. For example, here the location of the first point will make that different location, which is the centroid of that point. So because I do everything correctly and parametrically connect with the grasshopper, so if I change the point location, the all skyscrapers will be changed. So for example, here I will edit this parameter in order to make that the maximum 50. And here, make that 20. You can see how that will change. So that change the location. That means how is parametric design work as a tool, not as the approach. So if you want to integrate the approach, you have to apply the parameters, site parameters, factor requirement from the client, and the factor from the site to integrate with your design. And as I told you that before, apply the approach, which is evaluation of your design. If that's work correctly with your environment, work correctly with your parameters, work correctly with your factors, so you can call that parametric design. Also, the second section, which is inspiration from nature. That means you have to make research in order to get the shape, the materials, the behavior, the structure, the function of that object you doing research about, in order to understand that factors to apply in your concept. That is the concept of like the shape, materials, structure. You understand that object and you apply that on your like project. So the third sector, which is apply that by using parametric tools like RHINO, Grasshopper, or coding, or AI. So now you can do and call that parametrically. That project is did according to parametric design. So if I do that without any related to inspiration, without anything related to the approach, just parametric tools, that not parametric. That is just generating complex shape. Got it? So now if I create like this box and I open just one windows according to parameters, sunlight, noise cancellation from like street or client requirement, and test the best result if that's correct there, or I want to make that another direction. So if I test many options to get like best design, so that is called also parametric design, because that according to approach test many things, or that called benchmark, to create many objects, many items in order to get the best result of that one. So that is what is parametric design. So also you need to apply the inspiration to apply the materials or function there. So now you can see all the definition work parametrically. If I change the parameter there, so here 15, that will be make that here bigger. So also here, for example, if you want to change something related to the scale, so the scale of that one, so if I change the scale here, make that smaller, 0.6, you can see how that's look. So I hope everything is clear for you, and I hope you understand how to work parametrically by using these tools. And I hope don't using AI like just generating complex shape and call that as parametric. Make the AI integrate with your project like logically, not just like I like that form created by AI. Many clients come to me and ask me to create something related to something he generated by AI. So that not logic in architecture, that good for inspiration, but not for architecture and for parametric design, for a humanized architecture, for defined architecture approach or philosophy. So always, if you want to apply the AI with your project, make that integrate correctly, control AI, not AI control you. So that everything today. If you have any question, you can ask me privately on the WhatsApp, or you can ask me here in comments. If you have anything, we always here to assist you, and I hope you enjoy. So here we have the first one. Hi. So we have 5 minutes to answer your question if you have any question. Bounds. What means the bounds component? The bounds component is to calculate data between 0 and 1, the minimum and maximum. You can see the icon there, or remap work. Okay, so the minimum and maximum. So for example here, I want to apply this graph mapper. You can see between 0 and 1. If I duplicate this graph mapper, so if you apply this graph mapper here, you can see start from 0 to 1, and that is the minimum and maximum. So start from 0, 0, 0x to 0, 0x and y, and here to maximum 1 to 1 x and y. So you can see here 0 in x, y 1, 0 in y, 1 in x. So the bound work as minimum and maximum to calculate all the data in this grid. You can see here the grid here in gray. Yeah, so here in gray lines, you can see how that's intersection with this curve, and you can see many data there. So 28 data there. So that will be calculated by using the bound. So the bound, in order to make all this group of data and to calculate the minimum and maximum. So all your data inside that component, and prepare for remap, which is like source. So that means the source, like shaping the data between value and another value. So here, because we have the value between 0 and 1, so they shaped that between 0 and 1. And here we have the value which is integrated. So the curve which is in a black color with the gray and the red one, here was the value. Then we convert, so the remap number component convert the data from 0, 1 to this one, like 1 to 0, 75, or like previous graph mapper, which is between 0 and 1, will convert between 0 and 15. That opposite operation of reparameterize. When we use like reparameterize in order to make that between 0 and 1, so the opposite operation, instead of using reparameterize, we use remap in order to make that. Every data between 0 and 1 will be the target between 0 and 26, like 26 or 15. So that how that's work. So the first one, which is value from the graph mapper, second one, which is bound from source, like to calculate the minimum and maximum. The target is to transform that graph mapper to make that start from 0 into 15. So that here in before using remap, 0, 0, maximum 1, 1. After using remap, that will be 0, 0, and here 15, 15 in this corner. That how that's work. So that about the bounds and remap. How about the stadium design? So about the stadium design, that take a lot of time. So we organize that just for 1 hour. We can do that in another session if you would like to do that another session. If you like that live online session, we can prepare for next one. Could be after 1 week or less, or we can do that in another session. But I want to hear from you your feedback about our session today. In order to, if you like that, we can do that. We can continue with this like sequence of live sessions. So, thank you, thank you, like buttons. Thank you, appreciate it. Yeah, thank you so much. Anything else? Thank you, Ali. Thank you, Ala. It could be next session. It could be will you upload the live recording on your channel? Of course, that will be keep in live section. That reference for you. That for free, of course, for you. And we can prepare every month or every week for like this session if you like that online session. I hope everything understandable for you and easy to follow the parameters and how that's work. Most welcome. Thank you. So see you next session. Hope you are doing well and keep practicing.